All right, as we wrap up our unit on Lewis structures, let's go ahead and look at a few common bonding motifs and try to just get a general set of rules that will help us so we can inspect Lewis structures more quickly as we move on. So, hydrogen will pretty well only be seen with a single bond. If we were to consider oxygen, the most common bonding motifs would be 2 single bonds and 2 lone pairs. You might see oxygen with a single bond and then 3 lone pairs with a -1 formal charge. You could see oxygen with a double bond and 2 lone pairs. And then going forward, you may see oxygen with 3 single bonds and 1 lone pair with a +1 formal charge, but that is not as likely as the other 3 forms of oxygen, those bonding motifs. If we were to consider carbon, you could see 4 single bonds to carbon. You could see a double bond and 2 single bonds to carbon. You could see carbon with 2 double bonds. You could see carbon with a triple bond and a single bond. But for us, it would be extremely rare for us to see carbon with a lone pair on it. Now for nitrogen, we could see nitrogen with a lone pair and 3 single bonds. We could see nitrogen with 2 double bonds and a +1 formal charge. We could see nitrogen with a triple bond and then a single lone pair on it. And I guess in rare cases we might see nitrogen with a single bond and then a triple bond with a +1 formal charge on it. Other species that we might see would be halogens. If they're terminal atoms, we would see a single bond and then 3 lone pairs on them. Okay, so then the question is, when do things obey the octet rule, and when would they have an expanded or a contracted octet rule? So when do we know when to look for formal charge and minimize that, and when do we know to look for the octet rule? For the octet rule reigns supreme for second period. Then everything else, it kind of depends, but more times than not, you're going to try to minimize the formal charge as much as possible. So some common contracted and expanded octet motifs would be, for contracted, the most common one we would see is boron. But otherwise, for phosphorus, we could see something where there are 5 single bonds to phosphorus. It's rare, but it would be possible to see 6 single bonds to sulfur. You could also see maybe 2 double bonds and 2 single bonds to sulfur. You could see some variation with phosphorus with there being a triple bond and some double bonds thrown in there. But these are the most common contracted or expanded octet motifs. And these will tend to hold true if you're minimizing the formal charge for things that are in period 3 or lower. All right, I hope these bonding motifs help you identify some Lewis structures a little more easily.